Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Bakar. We're on Unit 8, Video 1, Operations on Functions. So, learning targets. I can add and subtract, multiply, and divide polynomial functions. We're going to do that. You guys should be fine with that. It's just the terminology you got to get used to. And I can find the composition of functions. That second one is, we're going to focus on that one. That's where you plug one function into another. So we'll get going right away here. Carol owns a store where she sells birdhouses. The revenue from birdhouse sales is given by the function r of x equals 125x. This is money coming in. So this is how much she makes when she's selling the birdhouses. Money coming in. Okay. The cost of making the birdhouses is given by this function. There's some upfront cost, $5,400, and it usually costs, it looks like about $65 per birdhouse. So this is the cost. How would you find the profit of Carol earns on her sales? Well, if you're going to find profit, or P of x, I guess you'd say, that's equal to the money coming in, the revenue, R of x, minus the money going out, C of x. So the cost subtracted from the revenue. Write a profit function for Carol's sales. So P of x then, we'll call it the profit function, is going to equal R of x, 125x minus C of x, the cost, 65x plus 5,400. Okay. So in order to do this, you know that we have to drop parentheses, and the only way we can do that is if we run a negative through that quantity. It's like taking a little negative 1 and distributing it through the quantity. So that's 125x. Negative 1 times 65 is negative 65x. And then negative 1 times the 5,040, well, that's going to be negative 5,400. So our actual answer is 60x. Combine these two terms. You're going to get 60x minus 5,400. So she's got to sell quite a few birdhouses before she starts really making a profit. If she only sells one birdhouse, that'd be 60 times 1 minus 5,400. That really doesn't cover the startup fee. So there you go, right here. That would be our profit function, P of x. Good. So let f of x and g of x be any two functions. You can add, subtract, multiply, and divide functions given these rules. Well, right here, f plus g of x. All that's saying is you're going to take the f of x function and add it to the g of x function. So let's let f of x equal x plus 2 and g of x equal 3x. So if I'm going to kick this in, f of x plus g of x, f of x is x plus 2 plus g of x, which is 3x. Well, it's addition, so you can drop the parentheses and combine like terms. X plus 3 of x equals 4x, and then you have the plus 2. So this would be f plus g of x. Over here, difference, f minus g of x. Well, that's just f of x minus g of x. So we're going to do the same thing. X plus 2 minus, well, there's only one term there, 3x. You really don't have to run a negative through that. But you can drop parentheses because we're just subtracting the 3x here. So x minus 3 of x is negative 2x, and then you still have the plus 2. So subtraction. Product. Product means multiply. This is f times g of x, not to be mixed up with f of g of x, and we're going to get to this later. This is an open circle. This is when we get into composition of functions. Here you just have f times g of x, and that's the same thing. F of x times g of x. So I'm going to take x plus 2, and I'm basically going to multiply it by 3x. We're just using distributive property here, so x times 3x is 3x squared, and 3x times 2 is right here, plus, we got 6x. So just understanding how these are written and translated into addition, subtraction, multiplication, division. Here where it's quotient f divided by g of x, it's just f of x divided by g of x. So writing it like this. Now we could divide this out, but when we're dividing in this section, you could be using synthetic division, you could spread it up into different terms. I just want you to write it as a division problem, and you can leave it like that. You don't have to simplify it. So f of x on top, that's x plus 2, divided by g of x, that's 3x. I just want you to leave it like that today, working in this section. So, given f of x is equal to this right here, x squared minus 3x plus 1, and g of x is equal to 4x plus 5, find the following. First of all, when you see this f plus g of x, that's the same thing as f of x plus g of x. So we add them up. The f of x function is x squared minus 3x plus 1. And we're adding that to the g of x function, 4x plus 5. And it's just a matter of combining like terms. Being it's addition, I can just drop parentheses and start adding. So it's x squared. That's my first term. There are no other x squared terms. Negative 3x and 4x are like terms. Adding them together, I get plus x. The constants, just your numbers, 1 and 5. And that would be your answer for f plus g of x. The other one here, b, I think we're subtracting. This is always going to be a little bit more work. Once you set it up, it's no different than any other problem you've had before when you're subtracting two functions. Hold on here a second. Okay. Let's move this over and bring this out now. So once again, f minus g, what does that mean? It means f of x minus g of x. And here's where we got to be a little bit more careful. You can't just drop parentheses. So when I get the x squared minus 3x plus 1, you are actually subtracting 4x plus 5 from it. Now when we worked with polynomial functions last chapter in chapter 7, we would always get the negative 4x, but we wouldn't make this 5. We wouldn't change the sign of that. So I'm just going to drop parentheses. Now the first polynomial here, you don't do anything with because you're not subtracting that. You're subtracting this one. So I'm going to distribute that. It's like distributing a negative 1 through there. Negative 1 times 4x is negative 4x. And negative 1 times 5 is negative 5. So you got to rewrite that. Or it's just the same as running a negative through it. Some people do this, but make sure you don't make a mistake. Change this to addition and run a negative through it. It's the same thing. I don't care which way you do it, as long as you do it right. And then you combine like terms again, like you're adding. So it's x squared, negative 3x, and negative 4x now is negative 7x. 1 and negative 5, that's going to give me negative 4. And we're done. So adding and subtracting polynomial functions, we're just working with when it's written like this, understanding what you do with it. Okay, so a little bit different functions here. Here's f of x, x squared, plus 5x minus 1, and g of x is 3x minus 2. So now we got times, this means multiplication, f times g of x. Well, that's f of x times g of x. So we got to do a little bit of multiplying here. F of x is x squared plus 5x minus 1, and this is times 3x minus 2. We're not really going to use FOIL here. It's kind of like distributive property. I would do this. You're going to multiply each term in the trinomial by each term in the binomial. That's 3 terms times 2 terms. You should have 6 terms altogether before you start combining like terms. I'm going to multiply 3x by all 3 terms first. 3x times x is 3x cubed, not squared. 3x times 5x is plus 15. A lot of people just put x, but the x times the x is x squared. Don't forget that. and then 3x times negative 1 is negative 3x. Now, multiplying everything by negative 2, I'll do that in blue. Negative 2 times x squared is minus 2x squared. Negative 2 times 5x is minus 10x. And negative 2 times negative 1 is positive 2. Now it's just, and you have 6 terms here. You can see 3 in red and 3 in blue. It's a matter of combining like terms. There is only one x cubed term. 15x squared, negative 2x squared. That is plus 13x squared. Negative 3x, negative 10x, negative 13x. And then plus the 2, the constant at the end. And there's our answer. So once again, you did this in Unit 7. Now we're just, it's written differently. We've got to rewrite it to solve that problem. Okay, so B. Now here we're dividing, and you could use synthetic division to divide this out. I just want you to write it as a fraction. Okay, so f of x, it's f divided by g of x. It's f of x divided by g of x. You don't have to simplify or solve this. I just want you to rewrite it. So f of x is x squared plus 5x minus 1 all over 3x minus 2. Now I could use synthetic division here to actually divide this, but for right now this is all I want for an answer. Okay? Good. If f of x equals 5x squared plus 3x minus 2 represents the length of a rectangle, and g of x equals 4x plus 25 represents the width of a rectangle, write a function that represents the perimeter of the rectangle. Well, first of all, here's a rectangle. And they said the length is f of x. So there's two f of x's. And the width is g of x. Okay? It says write a function that represents the perimeter. Well, the perimeter is the sum of all the sides. So if you add all these up, f of x plus f of x is 2f of x plus 2g of x is added together. That's 2g of x. I'm just going to take 2f of x. Well, that's 2 times f of x is 5x squared plus 3x minus 2 plus 2 times g of x is 4x plus 25. So I would just simplify this down then, and that would be your function for the perimeter. We could call this p of x, the whole thing, perimeter function. Anyway, doing the work here, multiplying all these by 2 first of all, 10x squared plus 6x minus 4 plus, distributing the 2 here, you get 8x plus a hundo, and then just combine like terms. There's only one x squared term, so that's 10x squared. 6x and 8x, that's plus 14x. And finally, oh wait a minute here, feel a little happy. 2 times 25 is 50, sorry about that. Then we got negative 4 and positive 50, that's going to be plus 46. So there's your perimeter function right there. You could call it p of x for perimeter if you wanted to. Very good. Okay, evaluating functions. Given f of x equals x plus 3 and g of x equals x squared plus x minus 1, find the following. First of all, simple. Something simple like f of 2. You're going to plug 2 into the f function right here. So that means 2 in for x plus 3, and this is just equal to 5. Very simply, you've done it before. It's just evaluating functions. The g of negative 3, you're going to plug that into the g function right here, not the f function, because it says g of negative 3. G is the title of your function, so that's negative 3 squared plus negative 3 minus 1. Negative 3 squared, a lot of people put negative 9 for that. That negative 3 times negative 3 is positive 9. Negative 3 and negative 1 is negative 4. So my final answer here is 5. But I think you guys will be fine with that. That's pretty easy when you're just plugging one number into a function. When we get to problems like this, it's a little bit more complicated, but it's the same thing, you're just doing it twice. Get rid of this one, get rid of this one, and we'll pull up this. F of g of negative 3. All it's saying is, first of all, you work your way from the inside to the out. So we want to find g of negative 3 first. That's going to give you some number. We just found it a little bit ago. We're going to do it again here. But then you take what g of negative 3 is and you plug it into the f function. So you're basically kind of finding two answers, and the final answer is the answer you're really working with. So yeah, we're going to find g of negative 3 first. Just finding this right here. And yes, that was negative 3 squared plus negative 3 minus 1. So it's 9 minus 3 minus 1. This is equal to 5. So g of 3, g of negative 3 is equal to 5. That's one answer. But now you want to take that answer because you want to find g of negative 3, that's 5. You want to find f of g of negative 3. Well, g of negative 3 is 5. So basically we're going to find f of 5, and that will be our final answer. So plugging that into x, 5 in for x, plus 3. My actual answer is 8. My actual answer is 8. So yes, we found the 5. G of negative 3 is equal to 5. But we take that and plug that into the f function and find our answer. So I'm going to let you guys try this one. G of f of negative 1. That's how you would say this problem right here. G of f of negative 1. So plug negative 1 into the f function, and then take that answer and plug it into the g function. So you can hit pause and try this, or I'm just going to try it right now. So we'll get rid of C, bring this one over. Work your way inside out. So first I want to find f of negative 1. Okay? And whatever that number is, I'm going to plug it into the g function you evaluated. So it's negative 1 for x plus 3. Well, this is 2. So f of negative 1 is equal to 2. So that means I want to find g of f of negative 1, but f of negative 1 is equal to 2. So I'm going to find g of 2 actually. Take your answer for the f of negative 1, plug it into the g function. So bring this down a little bit here. And plugging in 2. So I'm going to have 2 squared plus 2 minus 1. So this is 4 plus 2 minus 1, 6 minus 1. My final answer is 5. So g of f of negative 1 is equal to 5. Very good. Here's the next step, and this is basically the last step. Given f of x equals x plus 2, and g of x equals x squared plus x minus 1, find f of g of x. Now, all we have in here is an x. There's no number. So this becomes a little bit more complicated because I'm going to take all of g of x, which is all of this function right here, and plug it into f, the f function. We're going to plug that in for x in the other function. So basically you're plugging one function into another function. This is called composition of functions. Whenever you plug one function into another function, it's called composition of functions. Sometimes it's complicated, sometimes it's not so bad. But we're not multiplying here. A lot of students see this and they think, oh, I got to multiply f times g of x. No. If I wanted to multiply these two functions, it would look like this. F times g of x. And that is not what this is. We're not multiplying here. Okay? So how do I set this up? This is how I set it up. Well, what is g of x equal to? This is what g of x is equal to right here. So I want to find f of x squared plus x minus 1. I want to take all of this and plug it into the f function wherever I see an x. So, being f of x is x plus 3, it's x, but my x is now an expression, x squared plus x minus 1, plus 3. Well, now you just simplify. Basically, it's addition, so we're going to drop parentheses and combine like terms. So this is x squared plus x Negative 1 and 3 add up to 2. There's your answer. You're plugging one function, g of x right here, into the f of x for x in the other function. So one function into another one. Once again, it's called composition of functions. It can get a little technical. It's going to get a little technical with this next one. You're going to see that right now. If you struggle with this, hit pause, rewind, and look at it again if you want to. Or come up and we can do a problem in class tomorrow. That would be fine. So, not multiplying here. This is not what I'm seeing. It's f of x. I'm going to take this function and plug it into the g function. So I want to find g of, well, what is f of x? F of x is x plus 3. So I'm going to plug x plus 3 into the g function. That's what I'm doing here. Okay, so here's my g function, x squared plus x minus 1. So wherever I see an x in that function, I'm going to plug in the expression x plus 3. So x squared is x plus 3 squared plus another x plus 3 minus 1. So basically, to find this composition of functions, we're going to simplify. Now, we're not using power to power here. There's two terms. You have to FOIL this. X plus 3 times x plus 3. You can basically drop these parentheses now. Plus x plus 3 minus 1. So a little bit of work here, FOILing this out. X times x is x squared plus 3x. Done with this x. Now multiply by the 3. 3 times x is plus another 3x. And then 3 times 3 is 9. Plus x. I'll combine these two like terms. 3 minus 1 is 2. So final answer here, combine all like terms. There's an x squared. 3x, 3x, and x add up to 7x. 9 and 2 add up to 11. So this is g of f of x. You take an f of x and plug it into the g function. It's one function into another function. This is called composition of functions. Now there's a different way to write this. Okay, composition of functions right here. It says suppose f and g are two functions, then f of g of x equals f of g of x. This is just a different way to write it. This is just a little circle. It looks like a degree sign. You'll see it a lot of times like this. Just an open circle, f of g. Some people call it fog, but it's f of g of x. And basically it's just a different way to write. If you see this, you should think f of. We see f first, the g of x second, so we're plugging g of x basically into the f function. So fog, or if you did it backwards, it'd be gof, g of f of x. We're doing this one right here. So here's f of x equals x squared and g of x equals 3x plus 4. They want us to find f of g of x. Composition of functions. Once again, this is not multiplication. If it was multiplication, it'd be f times g of x. And that's not what this is. We're not multiplying. So there's a little open circle there. It's composition. So we're going to find f of, well, g of x is 3x plus 4. And all f of x is x squared. So I'm going to plug this 3x plus 4 in for x. So it's 3x plus 4. And that x would be squared. So once again, I can't use power to power here. There's more than one term. So we're going to have to FOIL it. What do we got? 9x squared plus 12x plus another 12x. And finally, 4 times 4 is 16. So this f of g of x is going to be 9x squared. Combine your like terms, plus 24x, and finally plus 16. This is composition of functions. You're not going to get a one-number answer because we're not plugging a number in for x. We're plugging a whole expression in for x. So that's the way it works. We're going to try this last one here. See what we get. Okay, they want us to find f of g of x. You could rewrite that as f of g of x. It's just a composition, it's the same thing, but we'll take that down here. That means we're going to take the function g of x, which is this 2x minus 1, and plug it into the f function. So we got f of g of x is 2x minus 1. I'm going to plug 2x minus 1 in for x in the f function. You're plugging one function into another function. So it's 3 times 2x minus 1 squared minus 4. So it's this function, but now my x is this 2x minus 1 right here. So a little bit of work. It's going to be 3 times this squared. Can't use power to power here. This isn't just 4x or squared minus or plus 1 minus 1, whatever. It's 2x minus 1 times 2x minus 1 because there's two terms there, minus this 4. I would FOIL this first, then we'll multiply it by the 3. So I'm going to put a 3 down here, some parentheses. 2x times 2x is 4x squared. 2x times negative 1, negative 2x. Now the negative 1 times 2x, negative 2x. Negative 1 times negative 1 is positive 1. Okay, we multiply these together and we have to multiply it by 3. And we have this minus 4 at the end here. Okay. So let's combine these two terms. 4x squared minus 4x plus 1. I can't work with this negative 4 until I distribute the 3 through the quantity. So I'm going to get 12x squared minus 12x plus the 3. And then we got this minus 4 on the end that we can tack on. So our final answer is 12x squared minus 12x and then finally minus 1. And there is your composition of one function into another function. And that's it. You can start working on your assignment. Once again, if you have troubles with this, work on one with a partner tomorrow in class, or come up and I will work on one with you, trying to help you figure this out a little bit. Peace out, Girl Scout.